Okay, so good afternoon, everyone. My name is Jadali, and we are from Group C. So our team group name is Ultraman Reboot. So my team consists of IRFAN, FARIS, and myself. So for the introduction of this project, there are four objectives mainly, which is to develop a factory layout that maximize space utilization, enhance workflow, and minimize waste for wood and metal-based manufacturing facility. Also, to ensure optimal allocation and usage of resources, including equipment, labor, and materials. Doing so will also improve the productivity and safety of operations through effective facility design. The last objective will be to integrate necessary supportive facilities such as storage, maintenance area, and administrative office into the layout design. So as for the scopes, there are two scopes. First will be the types of product should be wood-based, metal-based, or wood and metal-based with plastic as optional. And the new layout must be able to fit to the existing layout. So the assumption made for this project will be the material inventory size to be 5 times 6 meters each, and the product's inventory size will be 15 times 6 meters, and the operational department size to be 5 times 4 meter each, and the cost of the layout design is assumed to be 1 ringgit per meter. The layout has only one workers for each department. So this is the KNL table. So first, we already knew the product type, product material, also the product applicable industries. What we need to know will be the manufacturing process, manufacturing time, output rate per day, quotation of the product, and also product dimensions. What we need to learn will be the product structure, product design, facility design layout, inventory logistics, scheduling, and process flow. So this is the first product, which is the flush mount ceiling fan made by wood and metal, and has a total of 11 individual parts and 2 main assembly parts. There will be a total of 3 blades allowing air movement in a closed place area, and are built in with motor and light panels that could illuminate an entire room. It also comes with 2 different color sets, which are black and white, and it will be an aesthetically pleasing design which can fit into any styles of house. So this is the product structure of the first product. So mainly they will be made out of one main body and also a lighting assembly. And for the main body, there will be motor housing and also fan blades assembly. While for the lighting assembly, it will be built up with light fixture housing, light cover, light bulb, light sockets, and machine screws. So this is the BOM, bill of materials for the first product, flush mount ceiling fan. As you can see, this is the main. The first table will be the showing 2 main assembly department, which is the main body and also the light assembly. And for the rest of the tables will be the assembly of the individual assembly. For example, the fan plates, the motor housing, light link assembly, and also the main body. Next. So the second product will be the vertical bed. It is a versatile and multi-purpose furniture that comes with a bed, desk, chair, clothes rack, pillow, storage unit, and a ladder. It also comes with 2 sets of colors, which is black and blue or black and red. So the product is mainly made of wood, and is essential that is compulsory to anyone that looks for simple and versatile furniture in their home. It also has 14 parts and 3 assembly parts. So for the product structure for this product will be made out of 3 main assembly, which is the main frame, the ladder, and also the storage units. Next. So this is the bill of material for the vertical bed. Similarly, from the first product, it is made up from 2 main assembly department, which is the main frame and also the ladder. For the main frame, it consists of the bed frame and also the support structure. Next. And as for the ladder, there will be the ladder itself and also the main frame for the storage units. Next. And for this is the process flow chart for the first product. As you can see here, this is how how the flush mount ceiling fan will be made from this flowchart here. Next. And this is how the vertosol bed can be made through the flowchart. Yeah. I'll
Okay,
pass
so
to
so
Faris.
next we move to the process layout. So basically, the process layout is covering the two products that we study on. So basically, on the left side, we focus to put the inventory, which is for the material and also for the procurement inventory. So in the middle one, we focus on the process of produce the product itself, which is include the cutting, CNC, sanding, and also the testing process. While on the right side, we put the inventory for the storage after the product has been finished. So the next one is the product and demand for product 1 and also the product 2. So basically, this chart to observe and to identify the process and also the flow of the product to be produced. So basically, for the product 1, we can see on the left side, and also for the product 2, we can see on the right side. So basically, the quantities that estimate will be produced annually is 45,000 units for flush mount ceiling fan and 4,000 units for virtuoso bed. So this is the from to chart that have been developed based on the previous process. So from the observation, we can see that most of the relation of the process, the price that they require is between to 4K until 49K. And this is the PAYWAS method that we include in the study. So basically on the upside, we can see the formula of the total cost. So basically, the total cost formula will be used in the PAYWAS method to identify cost for each feasible exchange that we include. And also in the middle, we can see the layout of the workstation. We also include the assumed dimension for each workstation, and then from that assumed dimension, we can identify the distance between certain workstation into another workstation. So for PAYWAS method, we assume the cost which is RM1 per meter, and also we assume cost for initial layout is 3,189 ringgit. And then this is the result that we have identified. So based on the result, we able to obtain that the lowest total cost is on the exchange between the workstation J and workstation N, with the total cost is 2,911 ringgit.
Okay, next I will continue with the relationship chart. So basically, before starting to construct a real chart, we have to calculate the number of relationships. The formula is n bracket n minus 1 divided by 2. Since n is the number of activity included in this process, so there are a total of 15 activities are included. And these are the guide to produce the chart. And this is the relationship chart, how it is conclude based on the highest number will be labeled as A, which is the most important, and followed by E, I, O, and U. And as we can see from the relationship diagram, is the rearranged flow of process according to the importance and how frequent it is going to be used. And then we proceed with line balancing. So line balancing is necessary. It is to arrange assembly work at workstation, and it is also to ensure streamlined production flow. And this is the precedence diagram. We are required to conduct and construct this diagram so we can see the flow of the process and what are the precedents. And for line balancing, we are using largest candidate rule, LCR. So the first step is we have to list down all activities and the precedent for each activities, and including the work element, and then we have to rearrange all of the activities according to the work elements value, and we have to arrange it in descending order, which is the highest value on top and the lowest value at the bottom. Once we have done that, we have to assume the time cycle is 60 minutes, and then we rearrange according of the work elements and activity by not exceeding the cycle time. As you can see, for the first station, we managed to include 2 work activities, which is activity A and C, and there is no idle time, and then we continue with the next stations and until the end of the activities. The total time is 383 minutes, and the total idle time is 37 minutes. And then we have to calculate LBE and LBL. So for LBE, the formula is n times with time cycle minus time idle over n times time cycle, and we managed to get 91.19% after the analysis. And for line balancing loss LBL, the formula is n times with time cycle minus with total work, and then over with n times time cycle, and we managed to get 8.81%. And this is the after result for the new precedence diagram according to its arranged each designated stations. And for the findings, for the first one is cost optimization. We have swept department J and N from the initial layout to achieve a minimal total cost, which is RM of 2.911 million using the pairwise method. And then for line balancing, we using LCR, and then we able to classify all of the activity into 7 stations. We achieve an LBE of 91.90% and LBL with 8.81%. And then we managed to get the maximum space utilization, and then resource allocation and productivity. We managed to optimize the labor materials, which led to significant improvement. And then for supportive facility, we managed to get integrated storage, maintenance area, and administrative office to the layout. And lastly, product accommodation. The layout accommodate the production of wood-based, metal-based, and combined wood and metal-based product. And lastly, for conclusion, so the product has been successfully achieved its objective and maximizing space utilization, enhancing workflow, minimizing waste, and improving productivity and safety. The new layout was carefully designed from each aspect for the manufacturing process to be optimized. And overall, the new factory layout resulted in a more efficient and safe manufacturing environment. A careful planning and execution was made to meet and exceed the initial goal, which lead to facility that supports higher productivity levels. That's all from us. Thank you so much.